We're taking a look at the optional task. We're making the database highly available. This is for the Architect course, Module 10 Guided Lab. I'm Richard Golson, and let's take a look at this optional step. Now, we have a highly available application. We want to make the database highly available, and the database currently is not using multi-AZ. Multi-AZ ensures that a standby instance is launched into another availability zone. So the environment for the RDS instance has been set up to allow for this, because when you deploy an RDS instance, you deploy it into a subnet group where you define the subnets where the instances can be launched. And when you do this, you always have to define more than one subnet and availability zone. That is just a requirement with RDS. Whether or not you deploy anything into it, different thing. You still have to be ready to allow RDS to deploy it into a different subnet and a different availability zone. So that way, if something fails in the primary, it can, in the background, actually fail over to the other availability zone if you needed to. But anyways, all of that being said, what we're going to do is we're going to go ahead and deploy that standby instance in the availability zone too. And it's a pretty simple step. We're going to modify the existing database. So let's go ahead and do that now. So I have the database here selected. So what I want to do is hit the modify. Okay. And let's scooch this over a little bit. Okay. Now notice there's a lot of things that's pretty cool you can modify, because you could actually come in here and modify credential management, including the password. You can change the instance class and size. You can do things with storage. Here's where we're going to go from no multi-AZ to creating a standby instance. Okay. We notice that it doesn't allow us to do read-only instances because this instance class doesn't support that. So you can also see that it is using this lab DB subnet group, which allows it to leverage both availability zones. Okay. So we're also going to increase the size of the database. All right. So pretty cool. Let's go ahead and do that now. We'll change that to a dbt3 dot small. So double the size. All right. Super easy change. And then while we're at it, we're going to allocate more storage. So we'll increase the storage here to 20 gigabytes. Okay. So we're actually going to be doing 3 changes on here. Okay. And we're going to apply this immediately. So you'll see down below that you can actually make this less disruptive. Okay. Go ahead and hit the continue. When to apply immediately. We don't need to wait. This is a lab environment. If we had to wait, we would end up losing the changes. We wouldn't actually see it happening. So we'll modify our DB instance. And now in our optional second task 2, we configure a highly available NAT gateway. In this case, what we're doing is, instead of having a NAT gateway that spans 2 subnets, we create another NAT gateway. Right. So we create this NAT gateway pretty easily from the VPC console. So let's go ahead and expand that, and we'll go down to our gateways. Actually, I take that back. It's up here. There you go. And we'll create a NAT gateway. We'll give it a name. It's going to be NAT Gateway 2. So rather than creating a regional, we're going to do a zonal. So we can define where. Okay. So it's going to use public subnet 2. So we're going to go find that in here. All right. So notice it's showing me all subnets, whether they're part of this VPC or not. Okay. And then we need to allocate an elastic IP. And I think that's it for that. We'll create the NAT gateway. So now we have a NAT gateway in both availability zones. We're going after a truly highly available solution. So now instead of only one NAT gateway, and if this whole availability zone becomes unavailable, we have a second NAT gateway over here, so everything can fail over to here, and we're still highly available. We're still available, not highly available, because this RDS instance will become the primary, and we'll have a NAT gateway that the application server EC2 instance, if we need to do updates or anything, we'll be able to have that application server pull those updates from the update server. Okay, so now we need to configure the route table. All right. So we can go back over to the VPCs and get to our resource map. And what we're going to do is create a route table, because currently what we have is this one route table here that's being used for the private subnet. You can see that it's going to route traffic from both availability zones to that one NAT gateway. What we need to do is begin routing traffic from private subnet 2 to our new NAT gateway. So we can't do that on here. We have to create a new route table. So I'll use the link on here to get over here so I can create a new route table. Okay. So I'll have to back off a little bit and create a route table. This will be my private route table 2. That's going to be located in the lab VPC. Create my route table. Now I'm going to create routes and associate that route table to that subnet. All right, so let's go ahead and edit the routes. So I need a destination of all zeros. So this is internet bound traffic is going to go to this NAT gateway. It's NAT gateway 2. Great. Now I have to tell it which subnet's going to use this. So if I go to my subnet associations, I'm going to edit that, and I'm going to tell it to use the private subnet 2. Okay. Save that setting. And then finally, let's take a look at the map. And let's do a refresh here. May take a moment. It takes a little bit of time for the NAT gateways to deploy. Okay. But it looks like our private subnet 1 is going to the private route table 1. And let's scroll this so we can see the whole thing. All right, we don't need to see that side. So if I take a look here, here's private subnet 1 using private route table 1 using our original NAT gateway. Here's private subnet 2 using private route table 2 using NAT gateway 2. So that's all configured. Everything looks good. At this stage, I should have everything set up correctly, and I could submit my lab and move on to the next assignment. Thanks for watching. You've had a great opportunity with this lab to apply the high availability in an infrastructure as a service solution. Enjoy.